lot of different information or calculations from previous. We're just adding on a third value. So we are in three-dimensional space. So here we go. When a vector is in space with its initial point at the origin, we can describe it as an ordered triple. 3 dimensions. You have your x-axis, y-axis. Third one in 3D space, we call it the z-axis. So everything works the same as 2 dimensions. You just have that third value to deal with. Not that that's that big of a thing. So find the components of the vector with initial point 1, negative 4, 5, x, y, z, and then your ending point 3, 1, negative 1. So they want it in component form. So make sure you use the correct symbols. And then obviously just a little mental math. From 1 to 3, really tough question here. You went up how many? 2. And then do the y's. From negative 4 to 1, you went up how many? 5. And this is why I said you probably could teach yourself the first 3 pages here. From 5 to negative 1, you went down how many?
Negative 6.
Got it.
You're so smart.
Yay. So really, the first 3 pages is very simple. Okay, moving on. So the vector has that initial point. What is the terminal point? Remember, the vector is how you're moving the ordered pair, the ordered triple. So to get your final point, all I'm going to do is apply my vector. I need to subtract 2, add 1, add 3. Now, symbols. Let's talk symbols because nobody wants a lousy minus a half on tomorrow's quiz. We're doing points now, so notice I'm not using that vector component form. Just read that closely. All right, you already did this, right? That would have been minus a half for Owen. I would have felt maybe a little funny about that. Okay, so be careful on the symbols. Easy enough. Next up, magnitude. Magnitude is the same calculation basically as our 2-dimensional vector, except you have the third value. But it's still like that Pythagorean theorem. You're going to square root the squares. So find the magnitude. So I'm going to do 3 squared, 2 squared, 5 squared. So you might need your calculator for that, or 9 plus 4 plus 25. What's 9 plus 4 plus 25? 38. Now, and it will tell you in the directions on your quiz tomorrow, leave your answers in simplified radical form. I did go ahead and circle that because the square root of 38 does not simplify, just for the record. So the 2-dimensional stuff carries over to the 3-dimensional. All right, let's do the magnitude of this one. 0 squared, 3 squared, negative 1 squared, square root of 10, which does not simplify. Same deal. 0, I don't know why I'm writing 0 squared, but I am, I guess. So, of course, we end up with 1. All right, exciting stuff. Like I said, you probably could have blasted through the front page without. Any questions on that? So now that you get the gist that it's really the same thing, you just have a third value, that's all true on this next page. Because we're going to add the vectors together, but you have a third value to add. Same on subtracted. Same if you have a scalar, you multiply it to all 3. Very exciting stuff. So here we go. Find u plus v, u minus v, and 5u minus 3v. All right, let's do u plus v first. And of course, we're just going to add our corresponding entries, 1 plus 6. Negative 2 plus negative 1, 4 plus 1. Very exciting. Okay, u minus v. Of course, let's watch our signs. 1 minus 6. Negative 2 minus negative 1. So it's really negative 2 plus 1. And 4 minus 1. I like these because you really don't have any work. 5u minus 3v. All right, so a little more computation, but big deal, we can handle it. 5 times 1, I'm going to have 5 minus 18. 5 minus 18, negative 13. 5 times negative 2, so I'm going to have negative 10 minus negative 3, negative 13, or negative 7, sorry, negative 7. And then 5 times 4, 20, minus 3, minus 3, we got it, 17. I feel like I was starting to write the component. That's a 7. They're starting to blend together there. All right, got them all. No work necessary for those. Now, the only other thing we have really on this page is Avery's favorite, the I, the J, we're gonna throw a third letter at you, K. So, not that that's hard, but just, hey, we gotta look at it. So unit vector, remember, is our vector length 1. So we have our I for the first vector, J, K for the third, K for the third now. So as you can see, of course, you're gonna have the I and the J the same as the 2-dimensional. Your third dimension is the K. So write the vector in terms of I, J, and K. Well, that's pretty easy. 5I, and then we're gonna have minus 3J plus 6K. And remember, technically, but this is super hard to show, and especially writing pencil, even for me, like the vectors should be bold. But I mean, it's difficult for me to really do these bold. So obviously, I'm not going to get in a twist if we have everything bold. That's very hard to write, especially in pencil. And that's kind of obnoxious just for me to type all the bold stuff, but do what you got to do. All right, moving on. If U is that, V is that vector, express the vector 2U plus 3V in terms of I, J, and K. Okay, oh, mental math here. All right, so 2 times U, if it helps, think of that as a 1. So I'm going to have 2 plus 12. 2 plus 12, let's make it 14I. And the I should be bolded, but that's impossible. All right, I'm going to do the J now. So 2U, so 4. And then, of course, no J. So think of that as 0. So I'm just really going to ignore that. So 4J. And you tell me, what do you got for K? How many K? 15. Got it. So like I said, the first 3 pages I think you probably could figure out all on your own. It's just one extra calculation for that third value. Now, we've done dot product, of course. And you can see I've got it up here for our two vectors, our 2D vectors. Same process for our 3D vectors. We're just going to have a third calculation to make. And of course, formulas on your sheet. So you can see it, of course, you're going to multiply your first entries, the second, and then you have the third. Okay? But same process, same process. So I'm going to do my first entries, -6. Then I'm going to do the middle ones, 2 times 5, and then the last ones. And we're just going to total that all up for a grand total of. All right, same thing. We're going to do the first ones. So 2 times -1. I'm going to do the middles, -3 times 2. And I'll switch to red for the last ones. -1 times 8. So again, we're just going to total all of that up, -16. Any questions on the dot products? Okay, like I said, it's very similar. So next thing that's on here, which we're going to kind of do something a little different with it on the last page. This is the same, let me find it, same formula for our 2-dimensional vectors. Obviously, you just have a little extra calculating if it's a 3-dimensional. It's still the dot product. We just did dot products. We've done magnitudes of U and V already today, okay? So it's the same exact formula. You just have a little bit more calculating to do on a 3-dimensional vector. Big deal. Also, same rules. They're perpendicular. I like to say orthogonal because it sounds fancy. If the dot product is 0. That's true on a 2D vector, true on our 3D vectors. Okay, so show that it's perpendicular. So perpendicular dot product. We can do dot product. Okay, so first entries, 2 times 5. Code it again. Do the middle ones, 2 times -4. You could just put -8, of course. No, same thing. And then -1 times 2. And we end up with 0, which is why they are perpendicular or orthogonal, as I like to say. So really, have I taught you a whole lot of new stuff today? No. Which is okay. Okay. So last page, kind of where we have some new stuff for you, which is similar, but no. Okay, all right. So we're going to start talking about directional angles here. Now, Greek letters, just a little reference on our Greek letters, of course, alpha, beta, That one that looks like the Y, gamma. Alpha, beta, gamma, just in case you want to know that. So our directional angles makes our course is telling you which direction from the origin you're going with your x-axis, our y-axis, and our z-axis. Notice little three-dimensional prism here, we're working in 3D, just for the record. Now, one other little thing that's important to catch that's going to come into play later here, one of the problems, we want our angles in the interval 0 to pi, or in degrees, we're going to give some in degrees today, 0 to 180. So that's going to restrict some of our potential answers coming up in a minute. Now, to find your direction angles, it's pretty easy. So you're going to do the magnitude of the vector. Remember, this does not mean absolute value, it means magnitude. Magnitude of the vector, we know how to do it. Your first entry, second entry on top, third entry for the last one, and of course to get an angle, we're going to do cosine inverse, just for the record. So, find the directional angles. Well, first let's do the magnitude, because I need it for all the calculations. So square root, here we go. I'll throw one on there so it looks nice. 1 squared, 2 squared, 3 squared. So total it up, we have the square root of 14. Okay. All right. So we're going to do, I'm going to do them in order. There's 3 of them. So let's do alpha first. So it is our first entry on our vector, the A1, or 1 in our case. Now, we don't have to get worried about rationalizing. We're ready to go to the calculator. I'm going to do that calculator work at the end. I'm just going to set them all up. And then to get the second angle, beta, so our second entry, 2 over our square root of 14. And then we'll get our last one, gamma. I hate drawing this. It kind of looks like a Y. We're going to go with that. 3 over square root of 14. Okay. So, let me pull up my calculator. And you will see on your homework directions, it will say you can give your answers in degrees. And it will tell you what to round to. Just so we're consistent, I rounded everything to the whole unit here. Let's make sure this is in degrees. All right, so let's find alpha, of course, so second cos. And I'm just literally typing it in, 1 divided by the square root of 14. I'm going to round that. Let's go 74 for it. Why am I writing 75? We just said 74. It's a Monday. Okay. Do the second one, of course. You probably already have them all typed in. Square root. Keep typing on this thing. So let's round that one. Let's go 58 for it. Beta. That's a pretty good beta. I'm kind of proud of that one. All right, and last but not least, you tell me, what did you get for gamma? Maybe type it in. I'm going to try to write a decent looking gamma. It looks like a Y, yeah. What do you got for gamma? 37, Jackson for the win. Got it. And it will tell you, of course, in the homework or like on your quiz tomorrow, try to be super specific that I want them in degrees, rounded to the tens, rounded to the whole unit. It will tell you if it wants them in degrees, radians, etc. So you know exactly. All right, we are on the home stretch, believe it or not. So, and this is on your formula sheet too. All of this stuff is on the formula sheet. I feel like that formula sheet, there's a truckload of good info on there. So your direction angles too, because sometimes they might give you 2 of them and we have to find the third. Well, if you square them all, they should total up to 1. So we can use that to help us find the third one. So vector makes the angle alpha pi over 3, positive x-axis, beta is 3 pi over 4. Find the angle gamma with the vector, positive z-axis of 2 angle. Oh, gosh, okay. So much where you set. Let's just plug them in. So I'm going to have cos. So our alpha is pi over 3. And then I'm going to have, let's see, then 3 pi over 4 for beta. We're trying to figure out gamma, the y, equals 1. Okay, here's where you might need your unit circle, or maybe you know it by now. What's the cos of pi over 3, or 60 degrees? And just like that, the class has gone silent. Look on your circle.
It's 1/2.
I like it. So 1/2 squared. We'll square it in a sec. Okay, what about 3 pi over 4? Or that's 225 degrees if that helps the cause.
Is it also 1/2?
Well, I tried to give you the 225 because it's a multiply of 45. And it's going to be on the left side in quadrant 2, so negative root 2 over 2. Although in this situation, I mean, it does matter, but in this situation, does the negative really matter?
Probably not.
Because we're going to square it out here in a second, and we'll get to it. All right, plus co-square equals 1. All right, let's do some math. Let's square this, and I'm going to scroll it up here in a minute so I'm not way at the bottom. So I'm going to have 1/4. Square a negative cancels. Square a square root cancels. 2 squared 4. Yes, I know that can simplify, and I'm getting there. I'm getting there. Let me just scroll this up so I'm not way at the bottom. So of course 1/4, 2/4, 3/4. Let's subtract 3/4 off. So what is 1 minus 3/4? 1/4. And we're going to get rid of the squaring with a square root. 1/2. Technically, what should be in front of the 1/2? Plus or minus. But we have to talk about that. Now, we solved these equations back in that horrendously long chapter 7. We're trying to figure out what angles have a cosine or plus or minus 1/2. But at first I'm going to like, oh Lord, plus or minus, we would be in all 4 quadrants. But remember, one more. We're between 0 and 180 on these. So that eliminates the bottom half. So when I take a look, I'm just going to cross those off. So I'm thinking about the 1/2, because we have 2 potential answers. Cosine, adjacent, hypotenuse. What's across from root 3?
60.
Good work. I'm getting worried. So of course, cosine, adjacent, hypotenuse for the thrill of knowledge, root 3 again, 60. Now,
I haven't put it in, but oh gosh.
what was that, Avery?
It has problems.
Oh boy. Now, I'm not going to list both of those answers, okay? And it doesn't say if we have to be in degrees or radians. I'm probably going to give it in radians just because the given info is in radians, but whatever, it doesn't state it. Here's the key. It wants the obtuse one. So am I giving the answer in quadrant 1 or the one in quadrant 2? Quadrant 2. So if we measure from 0 over a course, we're really at 120 degrees. Which it doesn't state if you have to give degrees or radians, so I wouldn't mark off if you gave me that. But just because I see the other angles are in radians, I'm going to go with that. What's 120 degrees in radians? Yeah, so I'm going to go with that for my final answer. Got it. So this is, I can't even say this is new. This is the only maybe thing, we had to kind of take a look at a little bit is that formula to get the missing angle. Any questions on that? Okay, so keep your 9-2 homework. I'm going to collect that one from you tomorrow just in case you want to look it over for your quiz. I'm going to give you your 9-3 homework here so you can start working on that. And I'm going to give you back your